We are learning formation of partial differential equations by eliminating arbitrary functions, and this is part 2 of the video. In part 1 of the video, we first solved example 1. Then example 2. The link of the video is given in the description box. Coming back to example 3. Form differential equation by eliminating arbitrary constant from phi of a function of xy plus z square, comma x plus y plus z equals to 0, where phi is an arbitrary function. So again we have three variables are involved, x, y and z. Z we will treat as dependent variable and x and y will be independent variables. Since two independent variables are involved, that's why the resultant differential equation will be a partial differential equation. And as only one arbitrary function is involved, okay, so the partial differential equation will be of first order. It means to eliminate this arbitrary function phi, we have to take partial derivatives of first order only. So we are given this function xy plus z square x plus y plus z equals to 0. This is equation number 1. Let us take u variable as xy plus z square and v variable as x plus y plus z. So equation 1 becomes phi of uv equals to 0. This is, let us give these relation as equation number 2 and this as equation number 3. Now first we take partial derivative with respect to x. So we are taking partial derivative of equation 3 with respect to x. We will have del phi over del x uv equals to del over del x of 0. Now how to find a partial derivative on the left hand side, right? So we have phi here, phi function here. Phi is function of u and v, and u, v are functions of x, y and z variables, and ultimately all these variables are functions of x and y. These are functions of x variable and y variable. This is the tree diagram for finding this partial derivative. We have to find partial derivative of phi with respect to x. So this will be partial derivative of phi with respect to u. Why partial? Because u is not the only variable along this row. We have other variable v, right? So partial derivative of phi with respect to u, okay, but from u to x we can move along this branch and this branch, okay. So it will be partial derivative of phi with respect to x. It will be partial derivative of phi with respect to u, then bracket partial derivative of u with respect to x, partial derivative of u with respect to x multiplied by partial derivative of x with respect to x, partial derivative of x with respect to x plus partial derivative of u with respect to y multiplied by partial derivative of y with respect to x. And for u third branch, partial derivative of u with respect to z multiplied by partial derivative of z with respect to x. Then again the second branch will go pass through v variable, right? So this will be v, again 3 branches along x to x, y to x, z to x, right? So in this expression, in place of u will be replaced by v and the rest of the expression will remain same. So this is plus And the partial derivative on right hand side, partial derivative of constant function 0 equal to 0. So this entire equals to 0. Now this in this equation, partial derivative of x with respect to x, this one will be equals to 1. Partial derivative of y with respect to x. So x and y are independent variables. That's why this will be equals to 0. So this entire term becomes 0. Partial derivative of z with respect to x, we will denote it by letter small p. Again here, partial derivative of x with respect to x is equals to 1. Partial derivative of y with respect to y equals to 0, right? And partial derivative of z with respect to x, again we denote it by notation p. So the resultant equation becomes del phi over del u over del x. This term will become 0 plus p del u over del z plus del phi over del v over del x plus del v over del z multiplied by p equals to 0. And this is our equation number 4. So this equation 4 resulted out of taking partial derivative of equation number 3 with respect to x. Similarly, if we take partial derivative with respect to y, in equation number 4, wherever x variable is there, it will be replaced by y variable firstly, and secondly p stands for del u by del x. So in place of p, it will be del u by del y, and we will denote it by notation q. Okay, so similarly taking partial derivative of equation number 3 with respect to y, we will obtain in place of p, that is del z by del x, it will be del z by del y. We denote it by notation q. And this is our equation number 5. So from equation number 4 and 5, we have to eliminate the partial derivatives of arbitrary function phi. So how to go about it, right? So from 4 and 5 we can see, suppose in equation number 4 we bring this second term on the right hand side, and in equation number 5 the second term on right hand side, and then we divide 4 by 5. So all these partial derivatives of phi will get cancelled out, right? So what we are doing here is, we are bringing this second term on right hand side. So equality is here, this plus sign will be replaced by minus. Okay, in second term this goes on right hand side, so equality comes here, and this is plus symbols become minus. Now we're dividing equation number 4 by 5. So dividing equation number 4 by 5, left hand side by left hand side, right hand side by right hand side. This del phi over del u cancels out, del phi over del v cancels out with negative sign, and so after doing this exercise, we will obtain on left hand side, we will have del u over del x plus p del u over del z whole divided by del u over del y plus q del u over del z equals to del v over del x. This one is del v over del x plus p del v over del z whole over del v over del y, this term, plus q del v over del z. And we further simplify it by cross multiplying, so we get del u over del x multiplied by del b by del y, plus del u over del x into q del b by del z. Second term, p del u by del z multiplied by del b by del y, pq del u over del z multiplied by del b over del z, equals to, cross multiplying here, del b over del x multiplied by del u by del y, del b by del x multiplied by q del u by del z. Second term, p del b by del z multiplied by del u by del y. And lastly, pq del v over del z multiplied by del u over del z. So let us further simplify it. All this p and q terms, we are bringing them to right hand side. So bringing this p term on the left hand side to right hand side, we will get p of del u over del y multiplied by del v over del z, minus we have del u over del z multiplied by del b by del y, del b by del y. This is plus q. Now this term, we have del u over del z multiplied by del v over del x, minus this q term, we have del u over del x, del u over del x multiplied by del b over del z. Okay, now those terms, it does not involve p and q variables. We are bringing them to on the other side. So we are bringing this to the other side. So on the right hand side, we will have this term and this term. So we write it as del u over del x multiplied by del v over del y, minus we have del u over del y, and this is multiplied by del v over del x. P on all the partial derivatives expressions, they can be written in the form of Jacobians. So this one is nothing but Jacobian of uv with respect to yz. So we have Jacobian of uv with respect to variable yz multiplied by p. The second term will be this one. This partial derivative will form Jacobian of uv with respect to zx multiplied by q, and this is equal to, the right hand side expression is Jacobian of uv with respect to xy variable. In fact, we have derived a general formula. Suppose we have phi a function of uv variables, where u is a function of xyz, v is a function of xyz. Okay, so the resultant equation that is formed by eliminating phi from these two equations will be this equation, Jacobian of uv with respect to yz into p, plus Jacobian of uv with respect to zx multiplied by q equals Jacobian of uv with respect to xy variable. These x, y, z are changing their roles in a cycle, right? Yz, then zx, and then xy. So coming back to example 3, u and v are known functions of xyz. We will calculate all these partial derivatives using these two relations, put it here, and we will get the resultant differential equation. So del u over del x, okay, we will treat xy, u is a function of xyz. When we take partial derivative with respect to x, y and z will be treated as a constant. So partial derivative of u with respect to x, y will be treated as a constant, y multiplied by 1, z square will be 0. So this will be y del u over del y equals to x, del u over del z equals to 2z. Partial derivative of v with respect to x 1, partial derivative of v with respect to 1 with respect to y, and partial derivative of v with respect to z1. So substituting all these partial values of partial derivatives here, del u over del y, this is equals to x, del v over del z, this one is 1, del u over del z is 2z, del b over this one is 1. So this become x minus 2z. We get x minus 2z multiplied by p plus del u over del z is again 2z. This value is 1. This value is 1. Del u over del x is y. So we have got y. So the second term will be 2z minus y. 2z minus y multiplied by q. This one is equals to del u over del x. Del u over del x is, this one is y. This value is 1. Del u over del y is x. This one is equals to x, and this one is equal to 1. So this one will be y minus x. So this is the resultant partial differential equation formed by eliminating this arbitrary function phi from the given functional relation, where p stands for del z by del x, q stands for del z over del y.